Bill is in West Hartford, Connecticut. Hey, William, welcome back.
Yes, hi, George. Hi, Michael. I have a great question for you that involves microbes and viruses in relation to our space program, NASA. What I want to ask you is, NASA just finished a year ago this month the one-year microbiological space mission with the Kelly brothers, astronaut Scott Kelly and his brother Mark Kelly, who remained on Earth as a control. Well, astronaut Scott Kelly was in the International Space Station for a whole year with a Russian cosmonaut as well, and the first data started to come out a few weeks ago. Most of the of that mission was about taking blood samples and other things, urine and so forth, regarding the microbiome of astronaut Scott Kelly being in weightlessness for a full year, and his immunity as well. What I want to ask you specifically is, what benefits will us humans here on Earth get from that year-long space mission regarding fighting bacteria and viruses?
Well, thank you for that question, because it actually opens up the door, you might say, to an even larger question. And you use the term microbiome, which is a very important term today. It turns out that our body are swimming in microorganisms. There's actually more microbes living in your gut than there are total cells in your body. And we need these. They're what we call commensals, where basically they do a benefit for us. We provide them a place to reside. If we didn't have them, we couldn't digest our food, any number of things that we need in our body. The same thing is true even with our skin bacteria. Healthy skin bacteria actually helps keep away the bad bacteria. They compete for the same space. And so what we haven't understood for many decades with the use of antibiotics is that, yes, we need those antibiotics when we have a bad bacteria or, in this antiviral in the case of a bad virus. And when we use drugs like antibiotics, we actually have a big impact on the microbiome. We change it. We take out that kind of flora or the bacteria that's normally there that's healthy. And so we are starting to see more problems and we actually have diseases today that are actually caused by bad bacteria coming in where good bacteria used to reside, and we accidentally killed it. We didn't mean to. So the space program example you gave is just one more example to see how does the microbiome, that healthy part of microbes, actually reside in our body, and what changes occur. In this case, what happens when you go to space. You know, I'm always taken back by some certain kinds of entertainers and news commentators and talk show hosts who, and this program an exception here, this is not the case here, so let me be clear about that, but where they are so frightened by any microbe. Somebody comes in and takes a swab and rubs it across the telephone and says, oh my gosh, there's bacteria here, and it's like somehow these are all bad, and many of them are actually very good. So what we're learning today is that one of the ways to stay healthy is making sure that we had healthy bacteria with us and not the bad bacteria. And we need to do much more work, and this is what the space program study is working on right now, is how does that change occur. And I think the data, as you pointed out, are just starting to come out, and we really need more information about that. But we live with microbes. They're going to be here before we were here. They're here while we're here. They're going to be here long after we're gone. What we need to do is learn how to live with them and hopefully not have to fight them.
Michael,